Hello class, these are our informal geometry notes for section 5.2. We are working on proving triangles are congruent using side, 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 and side, angle, side. So that's what these S's stand for here. SSS is side, 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 and then side, angle, side. So we're reading at the top here. In section 5.1, we learned that for two triangles, if all the corresponding angles and sides are congruent to each other, then we know the triangles are congruent. In this section, we are learning that we don't need all of the parts to be congruent in order to conclude the two triangles are congruent. So, in this section, we can conclude that two triangles are congruent if they have three pairs of congruent sides. So we don't have to have all the sides and all the angles. If we just have three congruent sides, there's enough. So this is what side, side, side looks like. So we have one side marked congruent, and then another side congruent, and then the third side. So we can see like these two are the same, these two are the same, and then these two are the same, right? That's what we're looking for here. So let me go back and fix this and erase these extra marks here. All right. Note that we do not need to know that corresponding angles are congruent in order to use side, side, side. So we're just looking for three congruent sides. So the next postulate that we're going to learn about is side, angle, side. So we can also conclude that two triangles are congruent if they have two pairs of congruent sides and one pair of congruent angles. And these congruent angles must be the included angle. So an included angle is sandwiched between the two sides. So what that means here is if I look and I have this side congruent to this side, and let's say the side that looks kind of like a hypotenuse, let's say that that one's equal also. Well, when we're talking about the included angle, we mean the angle that's between the two sides. So not this angle down here, right? This angle is between this side and this side over here. That's not what we're talking about. We're talking about the angle that's between the two sides. Those are congruent as well. So that would be this angle and this angle. So think about how if I trace the sides on that angle, I get both of the sides, right? When I trace this side, that's the side I already have marked. When I trace this side, that's an angle that I have marked as well. So the angle has to be the included angle. It has to be the one sandwiched between the two sides. Another way to show that would be maybe this side at the bottom. Another way to show side, angle, side is that I could show these sides kind of at the bottom of this triangle are congruent. And then I could show that this one's congruent as well. And then the angle in between would now be this angle here is the same as this angle over here. So that's the angle. Again, if I was to trace this angle, then I can see that that's also along those sides. So the angle is between the two sides. Decide if the triangles, so now we're looking at our next set here, decide if the triangles show side, 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 angle, side, or neither. So we're trying to decide if they're congruent or not. If they are congruent, make a congruent statement. And remember, when we do congruent statements, they have to be in exactly the same order. The vertices on those triangles do. So for the first one, I can see that I have this side on my triangle is the same as this one. These are the same here as well. But remember, in order to have side, 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 or side, angle, side, I've got to have more information, right? Two sides is not enough. So I would either have to have the angle included or a third side. So what I kind of notice here is that I have this side, JK, is a part of each of those triangles. JK is a part of this triangle over here. JK is also a part of the other triangle. And since that side is congruent to itself, right, because JK is part of both of them, That gives me a third side. So now I want to go ahead, I'm going to write yes, it's congruent, and the reason is going to be side, side, side. And then I have to give a congruent statement. So my first triangle, I'm going to start at H, then I'm going to move along the side that has the one congruent mark on it, and then I'm going to go down the middle, and then I'm going to go up the one that has the two little slash marks on it. So let's see, it's going to be H and then J and then K. So if I put those letters in this order on the first triangle, I have to do the same thing on the second one. So first I'm going to move through the side that has the one little mark here. So that's from J to L. Oops, sorry, backwards, isn't it? So the first one I started at H, I started out on the point. So other way around. I'm going to have to go from L to J. And then I went down the middle. So L, J, and then K. So now I have my two congruent statements. So on the next one, let's see what we've got. We have that bottom side congruent on both sides. I have a right angle. And then again, I have the side in the middle congruent to itself. So yes, they are congruent. And that's because I have a side and then an angle and then another side. And let's go ahead. The first triangle, I'm going to say DBA. And that's going to be congruent to triangle DBC. So we have to list the sides and angles. The triangle needs to be in the same order. And this one, we ended up with DB congruent to itself. That's what allowed us to do that. All right, on the next one, it looks like I have another side through the middle. It's in two triangles that's congruent to itself. But this time what I'm noticing is I don't have an included angle. So an included angle would be this angle over here. This angle is not included between the two. And so I do not have side angle side on this one. So the order is not side angle side. It's actually side and then angle. So this one's a no. On the last one, I don't have a side congruent to itself, but I do have some vertical angles. So because my vertical angles are congruent, now I can see I have a side and then an angle on the side. So yes, side angle side. So I'm going to start at A here for my first triangle, and then I'm going to go to the middle. So A, C, and then B. And notice when I'm writing this one out, when I start at A, then the first side I'm going through is the side that has the two, these two hash marks on it right here. So when I'm looking at my other triangle, I need to start at D, and then the two hash marks are on the way to C. So it's going to be triangle D, C, and then E. So it's really important we list things in the same order there. All right, so hopefully this gives you an idea. I know if you move on, it says 2-column proof. We're not doing those in informal geometry. Formal geometry, we would do proofs, but we're not doing them. So key ideas are that we don't have to have all the sides and all the angles congruent anymore to show congruence. So we don't have to do that. We have this side, side, side postulate, and we have a side angle side postulate. And that not only do we know what those are, but that we can understand diagrams like this, and we can decide if we have congruence or not, and that we can list those triangles in the right order. So this is it for our 5-2 notes. Please make sure if you've got questions that you ask them.